At least we can start with a short presentation. I think almost all of you already have seen me this morning during the session, so you already know who I am. I am an environmental engineer specialized in hydrology and geomorphology. And I will show you a short introduction of the HortonMachine library. So the HortonMachine library do some of you already heard about this library? Do you know the HortonMachine library? No. So almost none knows this library. It is a library especially developed for hydrogeomorphology analysis. So it's mainly dedicated to whatever is related to geomorphology. Thank you. Geomorphology and hydrology. And its main purpose is to give some quantitative and qualitative instrument for knowing the morphology of the catchments. It has been applied in there were many applications of this library, especially on alpine catchments of various dimensions, and on different digital terrain model from 20 meters, especially in developing countries, to 1-2 meters LiDAR data. The history very short. It is something that has been developed during the last more than 10 years. Started by the research of a professor that works now at the University of Trento, Professor Riccardo Rigon, which implemented these tools, some of these tools, as a library in C, and then they have been ported in Grass and finally in Java. And now they are part of a special toolbox of UDIG and gvSIG. The concept at the base of the HortonMachine is that the morphometry is related to the erosion processes, and the erosion processes influence the morphology. So the purpose of this library is to analyze the erosion processes, incision processes of the network, and finally the possibility of flooding and landslides. Considering the main geomorphological processes in a catchment that are diffusive erosion on the hill slopes, network incision processes, landslides, and sediment transport in channels. Regarding the workshop, you will find your data in the W folder. If I'm not wrong, you should have a W folder. You already seen where there are the data? Okay. You should have two folders. One folder is workshop PDF, and the other one is workshop data. Let's start looking in the PDF. You will have two different files. One is the gvSIG tutorial, HortonMachine gvSIG tutorial, which is the tutorial we developed for these workshops. And here you can find everything about the workshop, step by step, and also the result and some of the theory explanation. And then there is, the other one, which is a quick start PDF to install the packages on in your gvSIG installation. And the other one is a folder called workshop data. You should have only the file dtm.zip. Please unzip it with whatever, but it should be extract the data inside the zip file, otherwise they will not be available for the software. So if you do it in the meanwhile, then we will use the data inside the folder. And so you will have a folder with this data, the ASCII data, which are which is the digital terrain model in different tiles from in ASCII format. Okay. Do you already know what is a digital terrain model and what it contains and how it is done? All of you knows this thing?
Yes.
Okay. So here I have also a section for the installation, but if you start to run gvSIG here, there should be everything installed already. So you should add the HortonMachine as a plugin in the experimental plugin of gvSIG version, and install all the HortonMachine packages available, and then restarting gvSIG. In your case, you should be already at this stage. You will see the HortonMachine menu, and you will have these entries in the menu. All of you have all these entries, especially the spatial toolbox entry in the menu.
No. We need to install the package.
Ah,
The
you don't
package
have it?
is not installed in any computer.
No, they should be installed. I understand.
No, no, no.
You have that. Okay, the spatial toolbox is the very important one. You have all spatial toolbox?
I miss tools.
See, but the very important one is the spatial toolbox, the first one. You have that?
It's only these 5 files, no?
Yes, but you don't need all of them. For example, EPA.NET, you don't need, but it is.
Okay.
It's the same. You can
Well,
go on.
I
go on.
try with one.
You have that? Okay. So, to access the HortonMachine package, just select the spatial toolbox. Like in this case, spatial toolbox. And then you should have this window. As you can see here, the HortonMachine is split in subcategory, in sections and subsections. So if you want to access different subsections, just click on the square before the name of the section, and you will see the list of the available modules. To select a command, you can just select the command, and in the right part, for example, if you open HortonMachine, then manipulation, the pitter, if you select the module here, it will open the window in the right part of the part of the window with the attribute to fill. Here there is also the possibility to search for a module, and so if you already know the name of the module, for example, slope, you can write slope, and then the software will show you the available list of the modules containing this word. So you can avoid to see every menu. Okay. So the main categories are basin, dam manipulation, geomorphology, hill slope, hydrogeomorphology, network statistics, and statistics. Oh, I had some slides here for to explain how it is digitalized the digital terrain model, but you already know everything here, so we can bypass these slides. Just one thing, two things I will add to you, that all these tools are based on the fact that the surface can be represented by a bivariate continuous function, where the elevation is a function of the position. And this function has a continuous derivative up to the second level, so everywhere. And the second thing is that the HortonMachine work only with square digital terrain models, not with rectangular or triangular digital terrain models. Okay. Another thing is that we work basically on a regular square grid and using the 8 direction topology. So this means that are you familiar with hydrology and hydraulic stuff? Almost analysis of digital terrain models and so on. This means that 8 directions means that you suppose that from one cell the water can flow in one of the 8 surrounding cells, but it has to flow in only one. So there isn't a middle path, a path in the middle of these 2 cells. Or so on. The software choose either this direction or this direction. Not other. Okay, so if you don't have any general question about the library or whatever, we can start with working with these tools. It is up to you how to proceed. I can proceed and do things and you can follow me, or I can show you just show you the presentation of what to do, and you can follow the tutorial and do it by yourself. Just let me understand what you prefer, because for me it's almost the same. I will stay here and wait, do things step by step. What do you prefer, to do it by yourself or to follow me? Follow me? Okay. So I have to run faster, and here it is very warm. So there are some preliminary operations to do before using the tools. And in particular, we have to create a new gvSIG project and import our digital terrain model. Then, since this is a very general workshop, we decided to give you not directly one tile of digital terrain model, but different tiles. So we have also to mosaic the different tiles. This is usually what happens when you practically do it with your data. So we thought that it is useful for you also to understand how to do this operation. So first of all, second thing, are you familiar with gvSIG? All of you? Oh, thank you. So I will just say do it, and you already know how to do it in gvSIG, like create a new project and fix the projection of the project, right? So let's start with this thing. So let's close this window for now. Open this new project that is already open and open a new view. I will enlarge it and set it to the projection of the digital terrain model. In this case, the data you have in the DTM folder are sorry. Okay, this is what you have in your folder. The data are ASCII files, so you can also see them with an editor, but there is also the projection file. If you open a projection file, you will see that the EPSG code of this data is 32632. So we can set it from the properties of the map, of the view. Selecting the view, you already know, I don't, should I say how to do it? And here there is the possibility to select the EPSG and then OK. So finally you will see here at the very bottom that your projection is 32632. All of you did this?
No.
32632. 3, 2, 6, 3, 2. You have to select the view here, and then these first properties, and then here there is this current projection. Click on the dots here. Here you should have here 4630 written here, and so you click on the dots and then select. If you don't have it in the recently used, you can select here EPSG and then search 32632 search and then okay. So now all of you is as a view with this right projection, right? Okay. So now we just take all the ASCII files here. As you prefer, import the DTM, all of the 6 tiles of the DTM in this view. I use the drag and drop, but you can use also add layer, I don't know, and all normally here. You can also use right click here and add the layer and then go and select your folder, or view, add layer, and again select the folder. And then take care of loading them all normally.
If you need something done,
Okay.
I will check.
No problem. Okay. Since they are ASCII files, they are not visualized very well at the first time in gvSIG. If you want to zoom to all, just go to this option here, icon. It's after the 2 zooms, plus and minus zoom. There is the zoom to all. Then I will show you, since this is a very general workshop on the use of HortonMachine and on the use of, in general, data for environmental analysis, I will show you also some other tools that we developed inside the gvSIG to help to manage the data. For example, if you select one layer here from the list of the available layers and right click, you will see the first option, single band raster styler. If you select this and then go here and select ELEV, since it is a digital terrain model, you can select the styler with the color table of elevation, ELEV, and then apply. You will see that it will be shown with a nicer color table, at least where you can understand the different colors. But you can also select grayscale, for example, and apply, and you will have this one. It is faster than doing all the configuration of gvSIG, and it has been done to speed up the operation to have an idea of the data. So now we have to merge the DTN tiles of the area of interest, and the tool that we will use is the one of the HortonMachine spatial toolbox. So we can go in the spatial toolbox and look for this mosaic 12. So open the spatial toolbox, HortonMachine spatial toolbox, and then write here mosaic, and it will be shown. Or otherwise, you have to go in Raster Processing mosaic 12. If you don't want to see it here, you go in Raster Processing, you open Raster Processing, and then select mosaic 12. Okay, this tool is called mosaic 12 just because it makes the mosaic of maximum 12 tiles. So take care of filling the first ones and not the others, because it opens the window at the end of the graphical interface, but you have to go up and select the rasters to use from the list of the ones loaded in the view. For example, I just go one by one, so I select the first one here, second, third, fourth.
In an order specific?
No,
the same?
I just no.
You can try different order.
I just go in
Yes.
order, because otherwise I have to read the numbers, but just select it. Take care of selecting all the 6 different tiles. There should be 89, 36, 90, 91, 37, and 35. Are you in the mosaic 12? Okay, just click go up in the window here, and in the map number 1 select the first one of the digital terrain models, and then map number 2 the second one. Oh, okay. First one is 889, 836 is the second, 890, 891, 837, 835. But it is not mandatory, this order. And then you go down till the end here, and then here you could select the interpolation type. The first option is the easiest one and the most quicker, is the nearest neighbor. Then there is the bilinear interpolation and bicubic interpolation. The complexity of interpolation increase going down here by cubic is the more complex, but it is also the slowest one. So I strictly recommend now to use the nearest neighbor. And also in this case, it has no sense to use the cubic one because the tiles are definitely with the same boundaries. So there is no need of giving a new, extracting new points from the interpolation of the available ones. So let the default value nearest neighbor here, and then select the path where to save your
The
your data.
interpolation method depends to the resolution of
No, the interpolation method depends only to you,
the resolution in the project, in the final project. Or
no,
not.
the interpolation method is something that is useful when you, yes, it is kind of a resolution, because if you increase the resolution, you will need it to interpolate, but it is not recommended to increase the solution and make smallest cells, because you are in any case inventing data. But if you need to increase the resolution, you have to use one of the other interpolation methods, yes. Or if you have tiles with different resolution, or that are not that do not have the same boundary. So maybe this tile is half of the cells of the other.
Yeah.
So at that point you need to interpolate, because otherwise, yes, you can choose the nearest one, but it is something that can do that. So yes. No, Alvaro, you should take one to me with this one, otherwise Basile will not be happy, because I strictly recommend to all of you to come to the Phosphor-G next year, which is in Romania, and it should be one of the, it is, you know, Phosphor-G, the big event of Phosphor-G. It's the biggest event of free and open source GIS software, and in this case you will have a presentation about everything. No, don't see. It's too warm here in Valencia. I'm used in Italy by us, and we have in the morning 0 degrees, so and that maximum 10 degrees during the day, but if there is the sun. So now I'm here sweating. Okay, so we can decide where you want to save your data. I did a folder called Elaborations, and I will put all the data inside this folder. Just let me try to okay. Anyway, I will call it DTM all. Take care of this last, I called it DTM_all, but it is up to you. But take care to give names that are representative of all the content of the of the elaboration of the map, because since there are lots of tools and lot of possible elaborations, at some point, otherwise, if you call it map 1, map 2, map 3, and so on, or if you call it whatever else, for sure you will lose the control of the things. So I just did this folder elaborations and call it DTM_all. Let's
está esa? Ah, pero es para guardar.
All not capital, I don't know. And another thing is that the HortonMachine needs that you specify the extension of the output file. So in this case, we want an ASCII file, ASCII. I write it in capital, but it should be all lower. But if you want to extract a TIFF, for example, just type it TIFF. Or if it is a vector, you have to type shape. This is a convention that we used because HortonMachine automatically recognizes the file type in import and also in written mode. So to give the possibility to recognize it in import, we had also to force it as output. So are you all here? Did you all did this? Okay. So to run a module in the HortonMachine, there are these three different icons. The first one is to run the module as it is here in the graphical interface. And this is, wait before running. Wait a bit. You already did it. You will wait. Because before running, there are two other important things to highlight. One is if you want to run it in debug mode, I recommend you to do it if you have some errors. In debug mode, you will see more log information. Otherwise, it will be not so useful. And then the memory, the Java space, the memory you will give to the process. So I don't know how many memory do this computer have, but give them not more.
8 gigabytes.
How many?
8 gigabytes.
8 gigabytes. So you can write here 5,000 at least, or 6,000 at least. You can also write 8,000 because in any case the process will take the resource available, not for sure all the available RAM. But I wrote it 8,000 and I have 12 gigabytes. So, but it is only something I always use. My colleague use everything the maximum, every time the maximum. So, but the more memory you put here, the faster, and you can do process on bigger data, because we have to use a lot of memory for these kind of tables, because rasters are very connected one cell to each other, and hydrological processes need to know the path, and you cannot split so easily between different tiles and so on. We tried to do some processes to split this and split on multiple processors, but it is not so easy for all the modules. So in this case, if you set this heap space, then you can run using the first option here in the very upper part of the graphical interface, and we just start and run it, and then I will show you the other options. Running will open this window, and then you will see the log. The other option to run is to run as an external script, or to save what is written in this graphical interface, save it as a script. So if you save it as a script, and you need another time and so on, you just personalize the name of the data, the path and the name of the data, and then run it as a script. And then you can also put different processes one after the other, and then run a script and go home and live all the night, because you know that in the morning you will find 5 different processes finished. Otherwise you launch one, and if you are not there, you cannot go on with the other processes. All of you finished the process? Okay, so we can close this log window and then go back to the view. I think we can also delete the DTM if you have all the digital terrain model. I just select all the files of the tiles and then right click and delete. So you will have only the digital terrain model, and if you select it and right click on it and select the single band raster styler again, LF color map, and apply, you will see the complete map of the digital terrain model. You see here there are some null data, and this data corrects the standard visualization of gvSIG, color table of gvSIG. But in any case, with this tool is very fast. You can fix the no value, also personalize the no value, the opacity, if you need to do something that is transparent, and very few things to be.
It's possible to modify the elevation?
The color, yes, but you can just modify them here and then apply this one instead of the
it's
standard
possible
one.
to modify these numbers?
See? Yeah.
Okay.
Okay, so we have now our digital terrain model. Okay, if you click on the layer and raster properties, you can see here that the pixel size is 2 meters, and we have a raster of 3,000 per 2,000 cells. Now, it's a fair. Okay? Yeah? Oh. You missed to specify the extension. Okay?
How do you apply the color map?
What, please?
I don't find the.
Where to choose the color map. Select the layer and then right click the first entry is the single band raster styler, and then select here in the second drop down menu element. Then apply, and you will have this result. Oh. Okay? Right click, single band, then use this second drop down menu and select LF.
I don't have this. I have in Spanish.
don't have it, just yeah, I just checked. Simple. Okay, if you don't have some other of your do not have this menu in the right click. Okay, so if you don't have it, you have to install another plugin, and so you just go here. I will show you tool. In the herramientas tools, add-ons manager, and then installation from URL. It is also written in the presentation here. The part we skipped was about the installation, so if you needed to do it at home, you have all the material to do it. And then next, mine probably is offline, or I have some problems, but in any case you will go on from that part. Okay, and then select, and then write in the search field Horton, and the one important is the simple tools. For doing this. You already did it. Horton here. Horton. Okay, simple tools. You have to select. Yeah. Yeah. Now you want it now?
The presentation.
Yes. I will give to one of you, and maybe if it is possible to write in the folder, the common folder, you can.
Yes.
Okay. Let's try this. tienes un pen? Sí. I will give to one of you the row, and then if you can share it, otherwise you have to wait a bit for the others.
It's not in the folder of
Yeah, it is not possible to
it's not possible.
write. We don't have
No, if
permission.
you run the
Workshop also, 2011.
if you run the
I will try, but it is also. It is not. But do you have a pen, USB? No, I don't want to switch it on because otherwise
Because it's
possible to
Okay.
that it puts my computer. If you have a USB stick, you can give me. I can copy it to you.
okay.
Otherwise, the file is there, and then I will try to find another USB stick. Workshop Horton, it is called. Oh.
Create a folder.
You want
Data.
data? GvSIG jornadas. Cartografía.
Horton.
Horton. Yeah.
I have a lot of problems to install gvSIG.
The portable or?
No, yes, the portable in the Mac.
Yes. You did it at the end?
Yes, okay.
If you need, I just tried. Sometimes it works for me, but I don't have Mac myself. So when find someone that has this, I have to go there and try to. But there is not Cesar, Orca. You can help them or write something to help people installing gvSIG portable on Mac.
I have the portable in Mac, but I'm not sure.
Because sometimes it works, and then you have to not to run the app.
Yes,
You go
yesterday
inside.
I tried different models, different versions.
Does it work for now on your Mac? Yeah.
Yeah.
But it's working now.
And I don't land
Now,
the,
yes.
the version.
There is a block in gvSIG that displays.
Yeah, but this is a bit tricky to make it
but it's
working. Okay.
Because sometimes even following that step.
Yeah, it doesn't work. Yeah, me too. And
Yes.
you experience the same. Yeah.
We need to make more tests in that.
Yeah.
It's because it's Mac. It's not easy to prepare it.
Yeah. For example, we don't have a Mac, so we cannot try to do that. So we tried to ask the professor that developed with us this HortonMachine. He uses always Mac, and he is in general very angry for this thing.
Yes.
Because it is very particular. But when I was at university 10 years ago, we were the only ones using Mac, and people say, "Wow, what is this?" and so on. But now, if you go in the classes, all the students mostly the 80% of students use Mac. So at certain point, if you want to that the software is used, you have to develop it for Mac.
Yes, I use normally QGIS because gvSIG.
Yes.
We are going to release a new version of gvSIG, the 2.5. So if you can test it, in Mac and say to us
Okay, but,
something about if it's working or not. Even we will tell you different methods to make it work, and it will be great for us if you tell us if it's working or not. Because it happened that says to us that just one line from outside of gvSIG application, it's preparing the Mac distribution.
Okay.
So it just seems who is making the test, and it will be great if people from outside tell us something, yeah. Because sometimes it's just to modify one file and it's working, or move a different thing in another file. And I don't know exactly Mac, but it's like that.
Okay.
So if you like to
I
ask,
check different guides. But
yeah, exactly. If one
Don't
doesn't
do-
work,
don't-
then the other one.
Yeah,
If it doesn't
try
work,
to restart.
because it's not one definitely.
No.
Yeah.
It's very slow.
For example, computer, in the, it is not available the gvSIG tools, one of the
Yeah.
different Horton tools in the server.
Yeah, I think in some computers, it's the gvSIG installed is not fully okay because it has some problems with the permissions.
Okay.
With write.
Yeah.
If it doesn't work, we can put the portable version.
It should be
which
already
is
deportable.
the difference in the portable version to the desktop?
No, there is now.
There is
Like,
no fundamental
it's
difference.
Oh,
It's just
sorry.
the portable
It
version is
is
just
here
unzip,
now.
and the other one you install it, and gvSIG folder goes to C, users, your name.
Should
So
work
in
now.
some places, like administrations or similar, they need the installation of the program because they install it all computers at the same time, like execute it, and they need that. But usually I work with the portable all the time. I don't have a installable version in my computer. It's not a big difference.
Okay.
It's supposed installation version is a little bit faster, but I'm not even sure about that.
Okay, nice.
Bien. At this point, we can go on and really start with hydrogen morphological analysis. So, first steps are here. Oops. We are here now, and then we can calculate some preliminary topographic attributes that are mainly the altitude, the slopes, and the curvatures. But in hydrological modeling, the height the height data is not enough because it is necessary that the height data are continuous, as I show you. So there is the need to eliminate the depressions that are inside, that exist inside the grid. What does it mean? You already understand what this means to eliminate the depressions that are in the digital terrain models. Okay, so we have two different tools in the HortonMachine to do this operation. One is the pit filler, and one other is the depitter. The depitter is the last one. We developed it last year. It is faster and it was better, but it is not so well tested. I recommend you to use the depitter now because it is very faster. Otherwise, you will wait longer for the elaborations. So we will do it now. The pit detection. So just look for the pitter here, or just go in the HortonMachine, then manipulation the pitter. Okay, select the map of the digital terrain model as input map, and the pitter creates two maps: the depicted elevation map, which is called depict.hash. Depict, I simply copy the name of the.
Do you need include the ask?
Dot hash. You have to include it. Yes. Take care of writing the extension, and then it also creates the flow dot hash, flow directions. I call it flow dot hash. Are you all okay? And just run it. Again, the map of the depicted is nothing else than another digital terrain model, but some cells are different between the input one and the output, and there are the cells where there are these pits, and the pits must be deleted because we need that the water flows. So finally, we need to give one of the the 8 direction to flow to the water. See? Thank you.
There is a tool to burn the digital evolution model with a network.
I didn't understand the question.
Want to that your network
Yes.
follows some specific shape, a blue line map.
No, we don't follow any shape. We extracting the network from here. We have 4 different ways to extract the network based on the total contributing area and the slope, total contributing area and concavity, the curvature.
The question is, there are tools that allows you to burn the
Yes.
digital evolution model with a network.
Yeah, you can do it, but manually. You can fix the network and then say, okay, on this, where there is the network with a map calculator, where there is the network, you burn 2 meters, for example. But we have a tool to avoid to do that, because we don't like to modify the data. And so what we do is to modify flow directions in that case, and force the flow direction to go through to the forced network. If you can do that, then you have the coherent data, because you base on the digital terrain model as it is, but the extracted network is the one that is in the reality, where there are some, for example, structures, so on, that deviates.
This tool for change the directions are in.
We just look where it is, but I didn't do any example of this. But I show you where it is and what you have to insert. Yeah, it is almost time to do that. Yeah, now. Okay. Did you finish?
Yes.
Okay. So you can just okay, if you select the pit, you can see the same as digital terrain model. or flow, for example. Flow, in this case, I give styling also to the flow, and the style is definitely flow. As you can see here, it is defined as all the 8 flow directions, and if you apply it, you will see the different hill slopes, an idea of the hill slopes. Okay? Yeah. So, now you can go on and do whatever you need to do with your digital terrain model. For example, the slope as primary topographic attribute, the slope distribution can be represented, can be extracted in the HortonMachine using 2 different tools. One is the gradient and one is the slope. Gradient is what one feels as a surface gradient. So it is the direction of the gradient which is perpendicular to the hill slope, the general hill slopes. So if you want an idea of the what you normally think as slope of a hill slope, use the gradient function. If you want to extract the slope following the flow directions, so from one cell the steepest slope to the next cell, so use slope. In this version, unfortunately, there is a bug. That is not a bug, but the slope routing is very low. Is very slow. So I recommend to use to test only gradient. In the next version that we already fixed it, it was just a matter of nothing. But anyway, it is fixed. So sorry, but on the repository it has not been released, the last version. But for today we just use gradient because it is faster in any case. Then there are other topographic attributes, for example aspect, which gives the inclination angle of the gradient, and the aspect gives you the idea of the exposition. Is something like the hill shade in the ArcGIS environment for QGIS or something. And then there are the curvatures, for example, and the curvatures are expected as normal and planar curvatures and longitudinal curvatures. So we can go on. Here you can see the composition of the curvatures of the 9 main topographic forms. So at some point you can see the convex divergent, convex parallel, convex convergent, just to have an idea of what the values represent. But you can find all the part related to the theory at the base of the HortonMachine in the HortonMachine manual. If you look in Google, the HortonMachine manual PDF, you will download it. So we can proceed now, and then, for example, calculate the aspect. Aspect is very useful because it is very nice because it is very useful also for printing and give a nice representation of your maps, because it gives this idea of 3D. In fact, there's a 2D and it's called 2D and a half. And if you select aspect and select the digital elevation model, I recommend you to use always now the pit. Usually I delete the DTM from the list of the layers here, just to avoid to use, for example, the DTM and the flow directions, because the flow directions are calculated on the pit and not on the DTM, because the pit is the one that is hydrologically coherent, and the flow direction will give you probably errors, because at some point the water cannot flow anywhere. So here use the pit. So then you can choose if you want to create the output map in degrees, otherwise it is in radians. And if you want to round the raster maps, but it has sense only for degree maps. And then the map of aspect, aspect.ash. Aspect.ash. I really don't choose any other names. And then run it. And again here, if you want to personalize I usually give it a bit of opacity, and then aspect color map, and apply. In this case, if you visualize the pits, should be more. Why not? If you use some opacity, you will have this kind of 3D representation. I don't know if you want to go on till the end, or if you want to take a break, to have a break now, or whatever you prefer. You prefer to go longer and finish at 6:15 or so. I don't know. It's up to you.
I prefer to continue.
Continue? Okay. Okay, so all of you have this map of aspect. So we can go on, and the other map is the gradient. You can also do it by yourself. Oops, sorry. By yourself, you already know that how to do gradient. Select the map of the pit. The formula, this is definitely the default one, is the mostly used one. Here again, if you want to extract the tangent of the angle, or if you want the true values of in degrees, I usually leave the default values, because if you leave default values, the map is ready to be input of probably another process. If you use personalized values, take care of understanding if when you will use the map in other processes, if they are if the measures, the unit measures are compatible. The map of gradient is gradient.ash. Okay, and run it. And again, here, if you want, you can personalize the style. In this case, a rainbow, for example. As you can see, we have some outliers, because the color map is not very defined. And if you put aspect on the top, you will see again you see here, these are very steepest hill slopes. These are the steepest points. Okay, and then the curvatures. So again, the map of the depict as input, and profile curvature prof.hash, planar curvature plan.hash, and tangential curvature tan.hash. Or curve, it would be better to write curve, tan, curve. I call them curve. Okay, can run it. The curvature maps are very particular because there are practically always outliers, so you cannot feel the different values of curvatures very easily. Even if you choose to visualize to use a rainbow or a rainbow map. As you can see here, it's not so easy because these are outliers. So the default map color tables are not so. This is one where you can see different curvatures. This is the profile curvature, and the tangential curvature also can be something. Where you can see some stuff, different stuff. Okay, Did you all do the curvatures? Problems, questions? Okay. So we can now go on with the drainage directions. The depictor tool already started the drainage directions, but the very simple drainage direction based on the simple D8 model, which is the standard tool where the flow is considered to go only in one of the 8 different neighboring cells. Considered to be here, and the DH consider these directions almost. So if the value in your map of flow is 1, it means that the the flow is through east. If it is 3 is north, 5 is west, and 7 is south. And the other are the intermediate values. For sure, this representation is not so coherent with reality. And even if it is coherent locally, if you have a big basin, you will accumulate the difference between the real part, for example, this one, and the one you will choose. If you are here locally at the beginning, the difference is very narrow, but if you go here, probably this is north, and otherwise you will have east, for example. To avoid this problem, the research on this problem is very high, and different tools are available in almost all the GIS software. For example, QGIS uses the Tarboton processes, and we decided to not to use the Tarboton process, and we decided to use another process that is based on the theory of Landini et al. Of 2003, which uses an approach to evaluate the difference between the angle or the distance between the real flow path, local real flow path, and the one that is coming from the from upstream, and then correct it if it passes a threshold. So definitely we have this calculation local, and if locally you have this flow direction, because from upstream you will have this flow direction. If either the angle or the distance here is higher than a threshold, then it will be corrected to the nearest one to the local right values. So this tool is implemented in the reindeer. This theory is implemented in the reindeer method tool. So we can start the reindeer. You have to select here the depicted digital terrain model, the map of existing flow direction, the one based on the DH flow, and then it will create the map of drainage directions, drain.dash, for example, and automatically also the one of the total contributing area, tca.hash. I will leave all the other parameters as default. This parameter is the direction correction factor, the threshold, and this is a switch between using the angle or the distance as the threshold. Here we have also the possibility to insert a map of flow direction forced on a network. So what you have to do is to take your first network, or just a piece where you want to correct the extracted network.
Vectorial network, for example.
Sorry?
Vectorial layer.
See, yes, but you have to rasterize it. The raster and create the raster of flow direction on the network. So if you have this vector, for example, and the extracted raster of flow direction is right until here, and then goes here, and then down here, for example. This is the rasterized network, extracted one, and you want to force this one in this part. You have to rasterize this vector only in the part where you want to change it, and then for these cells, or the interested cells, now I'm doing something. Okay? Here you have to assign the flow direction. You can extract them and then cut it on here and maybe change whatever you want to change, or manually giving these values, and then give this input file to this.
All the other cells of the map with no data value
will kept as they are. Yep. And if you want to change two pieces, you can do it in one step, making these two parts, or if you can do it in two different steps with two different rasters. So.
Yes, but the extension of the raster must be the same extension that.
Yes, better. Yeah.
So all cells with no data value.
And only those values you want to change, to force on them, and then the tool will force here to go here, and then keep all this flow to these other flows. Then probably something a bit further, that the network will be already in this kind of direction, but the network will be extracted on this kind. We did it for our work on the Venice Lagoon, because there everything is artificial and everything is very flat. So, and it worked very well. And so it is just a matter of starting to do this this map of flow direction, forced flow direction. But it is easy to find some tools to help you to do that. For example, we have a tool here. In our, we developed a tool. Let's visualize this. If you zoom very close, you can select the layer here, right-click and raster graphic view, and select if you want the raster values, for example. It will show you the values, and also, and in this case also the steepest direction, because otherwise you can do that only with steepest directions, or just visualize rows and columns. In this case, if you have a raster, you see the rows and columns of the cells you want to change, and definitely do it very faster.
For a grid extension, it's a very hard task, I think.
Yes, I think I will do that on very small maps, and then use a map calc to give a bigger area to the raster. It will be easier to do that. So you create raster locally. There's a tool here also. You can raster value copy. What you see here is copied in a text file. If you open a text editor now and paste, it is already in a format of hash file. So you visualize the piece of the area you want, where you want to change the things, create rasters on this area, work on this, and then the map of the flow direction, you use one of the process, I don't know, here in the Raster Processing, the Raster Converter, for example. Here you can convert an input raster and give in the new region. If you take care of using the same virgulas to commas to not to have cells at the middle of the other cells, you can. But if you do it with our tools, it will keep all the information coherent. So when you pass to the smallest, you have the resolution where the angles of the cells are the same of the original ones. And so when you pass back to this with the biggest area, it is automatically done. It is not easy. We worked only on that project on this, and usually we don't use it so much because in mountain catchments it is not so mandatory to follow exactly all the network. And then if you use these tools for hydrology, when you arrive where there are the cities of human-made structures, you have to evaluate the discharge there, so you close the basin there. And so at a certain point, we didn't develop anything more specific for that. It is also possible, for example, to definitely carve the digital terrain model using the so-called Bob the Builder. I think tomorrow I have a presentation. There should be also some of these tools. Bob the Builder is one other tool, which is not definitely an HortonMachine tool because it is not so scientific based, but it took a raster map and two vector maps, one with a polygon where to modify the area, so you can define the extension where you want to modify the area, and then the other one with points where you fix, for example, elevation and so on. So in this case, for example, you have another stream here, not that one, another here, that it is correct, and you don't want to modify this one. So you can give the polygon as only this area, because you want to modify only that area, and fix some points here. then define the radius of influence of this point, and then it will make an interpolation of the data of these points, spatial interpolation, and fix your digital terrain model. Otherwise, if you want just to carve the network, just carve the network, it is very easy. You can use the tools, the Raster Map Calculator here. We don't see it, but you should use some specific syntax. You will find documentation on the website, and an if function. You say if I don't know. Okay, the pit is the one of the map, and consider to have the network here. I just use this, and say if should be added something before this if, but just if curtang is different from 0 or is equal to 2, which is the value that we will see represents the network, the pixels of the network extracted by the HortonMachine. Otherwise, you will have a network with 1 rasterized with the value of 1. You can put it if it is equal to 1. So result is the pit minus 2 meters, for example. Otherwise, result is the pit. If you do something like that, you can carve only the network, the pixels of the network.
But the results is possible to analyze with the normal raster calculator. There are some difference to apply the raster calculator to the HortonMachine raster calculator.
No, it's the same. Yeah, but this raster calculator is made for making formulas. So you can do elaborations here. If you want to put a formula A plus DTM minus 5 or do your own interpolation because you know how to do, you can insert it here and
with that expression he makes a loop through all the cells of the map.
Yes, all the cells you give will be treated in this case, and it is almost the same. If you have in the network map, if you have only 3 cells, we said that if there is this vector map, if the values of the raster of network map is 2, do it. Otherwise, no. You can have a vector, a network map. It's late. A network map with different values of the network, because one is the very heavy, the principal, the main channel. So you can see where there is 1. So I want you carve DTM minus 3 meters. Where there is 2, put 1.5 and 0.5 in the others. It's just a matter of thinking of what you have to do, you want to do. I don't know what you use now to force this thing, but I think
because when you make some hydrological work for the administration,
yes,
administration wants to see
that
the
network.
same, official network that they have.
I know that. So we also try to convince them that it's not so basic to have that. But in fact, if there are only very few parts, you can use this tool. Maybe it is also nice because you can use, for example, a double check. You can use the network and check if for example, we have the possibility to extract the enumeration, the level, like the Strahler enumeration of the network and so on. So you can give different thresholds to the different order of the network. That can be also. The tools the tools are inside here. We use them all. It is not so easy to show you all the tools because a lot of people want to come to this workshop and have a fixed number of operations to arrive to finally evaluate the maximum discharge. So if you don't arrive at the maximum discharge, people is not happy. But there is the tutorial now, and you can definitely follow that. It is, I think, very clear step by step. So I hope that that one. So these tools, tomorrow I will show you in the presentation very briefly these tools, all that we already see now. So it would have been better to make this workshop after. Anyway. So, did you already run it? Because mine, no, the reindeer was here. I have to do it again. The pit flow, and then drain.hash, and PCA. But if you have any questions on about how to solve some problems you have, or if you have any idea on what could be you would like to do and you don't see here something that it is already prepared, just ask me. Maybe I have some idea. Maybe now it starts to be late, so maybe tomorrow I have some ideas on how to solve it. Okay, run it. So maybe for you Spanish is not late, but usually we in the very north of Italy, not in the south. In the south it's close to you. It's not so in delay like you, but in the very north we have. I'm a bit scared to tell you at what time we have lunch, because I think you have the second desayuno at that time, because at midday we go to lunch. The very later ones go at 1, but in the north you have to have meal at midday. So just to joke, every year when we come here, we say to Alvaro and the others, guys, the dinner is too late for us. We have already finished from 1 or 2 hours, 1 hour. That's the first, but 2 hours before this one, you start to have dinner at 10. Okay, so run it. I did it. Yes. So drain is another map of flow directions. So just give the flow color table, and then zoom to layer. Yeah. If you visualize it and the flow, you can see that there are some changes. Then you can go locally and inspect these changes. But just a short view, you can see that with the slope, with the flow, the hill slopes are very. There is the same value. There is. It is difficult to have to appreciate local morphology. And if you have this LiDAR data, so precise data, it is better to use them. And so if you use the drain, the results are better. And then if you, I don't know if you already know the map of total contributing area. You know what it is, total contributing area? I think I have here. Okay, no. Okay, total contributing area is, in our case, represents the number of cells that drains in that cell. So all the cells that are upstream and contribute to the discharge in that cell. Okay? And it is in this case the number of cells. So if you need to understand, to know the area that drains in that cell, you have to multiply per the resolution of the map, X and Y resolution. And in this case, for example, the styler to use normally is logarithmic. Logarithmic, you can appreciate something much more, because most of the cells have very low values of total contributing area, and the ones that are in the channels, especially the main channels, have biggest values. Very big.
It's possible to modify the color of the legend, or
the ranges, yeah. So let's take logarithmic. Okay. So now that we have almost all the information, and we already extracted with this TCA, we have a great idea of the network, because here you can see where there are the biggest values of this total contributing area is where we will have water inside, so we have the network. We can so extract the network, and there are different tools, different options to extract the network. One is on the total contributing area, only on total contributing area, and it is just to fix a threshold on the number of cells and consequently the area that drains in each cell, to consider that in that cell there is water in surface. To how can I say, to give a reasonable value of this threshold, you have to either have a map of existing channels, or go in the field and understand where in fact you see the water in surface. Otherwise, you can just define what it is almost coherent with an extraction. Do not have too many channels, but also not only the main channels. And this is just a matter of calibration on your process. It depends on the type of terrain and mainly on the terrain types, I think. Yes. Then it is possible to extract the network based on the product of two quantities. For example, the total contributing area and the gradient. So it represents the possibility, the tangential stress to the bottom, and in this case the capacity of erosion of the water. And then the other is the total contributing area in convergent sites. And in this case, in these two other cases, you need two additional maps, the map of gradient and the map of topographic classes, where you define if you have concave sites or convex sites. We do it just for an example with the easiest way, extract network. The map of, well, why it doesn't show me all the other maps? Extract network. Okay. The map of total contributing area. The map of flow directions. Take care that the map of total contributing area is calculated on the drain and not on the flow. So again, go in the view and delete the flow. We will not use this map again, or either. If you want to use the flow as original DH direction, you have to calculate the total contributing area with this map with the tool that extracts the TCA. So here you specify to use the flow, for example. Okay, I deleted it. And it is possible also to evaluate the 3D TC, total contributing area, considering also the difference in elevation. But now we were in the extract network. So TCA and drain. Here an optional map of the slopes. Here the optional map of aggregated classes for doing the other two different ways, either one or the other. The threshold on the map, I don't know, in this case I will put 2000. The mode is only TCA. The exponent leaves as default. And the extracted network, usually I call it net underscore the threshold, which I'm using 2000.hash. Because it is a matter of calibration, maybe we will have 3 or 4 different testing maps, so it is good also to write the values inside.
It's possible in the threshold use the other shapes, no? In the thresholding mode.
Yes, the TCN slope.
Yes.
If you select this, you have to put this map.
Okay.
If you select the other, you have to put this one, and otherwise only this one.
But it's better to use it for...
It depends on the terrain and on the morphology you have. Because if you have geology and morphology are combined, if there is a terrain that it is very influenced by the for erosion, so better to use also the stress, because this is the process that is important for that basin. Normally basins, the biggest ones, so in particular, it is better to proceed with only total contributing areas. But if you have to do something local, very special or so on, I usually try with this TCA, and then if there are some problems or so on, I try to use something, some of the other two methods, and otherwise force the network. Okay, then run it. And here is the map. The map of the network is a very easy map. It has no values everywhere, minus 1992, and the value of 2 in the network. So if you need to do some map calculator, or if you need to do something else, just look for the values of 2. And since we are here, we go on with the last thing, I think, which is the extract basin. So extract basin extract the watershed at the closing section, and you have to specify the closing section by entering the coordinates, or just clicking on the network. Take care of clicking on a pixel of the network, otherwise it will extract the basin of a pixel on a hill slope, which is right, but it could be probably something invisible for you. So in this case, zoom very, very high on where you want to select for example, a trick is to select the pan tool, because if you have the zoom tool, it's not so easy to manage it. And then, for example, I want to extract this basin. I don't know, you can decide your basin. So I go very, very close to the path, and then look for extract basin. Here you can put the coordinates. It's also easy to understand the coordinates, because in the HortonMachine tools position info, this is position, and if you go here, you have automatically copy the east and north of this.
Repeat.
You go HortonMachine tools position info,
Okay.
and here you click. Why doesn't and then you can choose also to transform it directly in another reference system. For example, you need the coordinates in left long, and you don't have and you don't want to reproject all the map, so you can specify it. But in this case, if you see here, clicking on the map, the coordinates change automatically also in the HortonMachine as the closing section. Take care of clicking on the network again, and
But you are copy the.
no, just it is automatically here in the spatial toolbox. If you click here, automatically keeps the coordinates.
Oh, nice.
Okay. And then insert the map of flow direction, which is drain. If you want to snap it at the map of the network, it is possible also to fix the buffer. But usually, if you use this to zoom close, it's better than use the buffer. And then the extracted basin mask, for example, basin .hash. The outlet vector map, if you want the point of the outlet, outlet.shape LP. And
You need to write the extensions.
yes, always the extension.
Okay. Don't copy the.
No, it's a matter of
Automatic.
development.
Okay.
basin, extracted basin dot shape. For example, in this case, I have to give a different name between the raster and the vector, because otherwise, when you go on with the elaboration and keep those two maps loaded in the view, the gvSIG tools always make confusion on the raster and the vector, for example. Okay, and then run it, and then I want to see who of you didn't select a point in the network. And I zoom on this map of.
But it's not possible to create the two the all watersheds in the drainage.
The different watershed
Yes.
at different areas.
Yes, the complete.
Yes. That there is this split sub basins or other net numbering, for example, as you can put here. The map before doing this, I think you have to extract a bigger basin. You have to have only one outlet in any case, and then use this net numbering. I will try, but I'm pretty sure you need only one outlet, and the map of TCA, and the map of the network. This one. You can fix also some monitoring points, so-called, where you want to, in any case, close a basin. The threshold value on TCA is the dimension of the basins. I don't know how many cells. We have cells of 2 meters. I don't know. 3,000. I don't know. No.
It's not possible to measure with other tool.
Yeah. It is possible to. I don't know.
Yes.
For example, the info. I want to start.
In the tool of the consulting design. The third tool, the measuring distance. No, in the main view. Information, this one.
Why measuring distance?
No, it's possible to use this tool for measure the total.
But it is a number of cells.
Okay.
So it is better to see it from the TCA. For example, this 100,000. I don't know if.
Sorry.
I don't know the name of Kenyan. Nothing. Dash and sub. I think that it will not work because there are too many outlets. Do not find value attribute in the channel after point. Yes. This is the problem. You should have. Okay, I can do it. I should cut out all the data on the extracted basin, and so if I would have a bigger basin, or also this one, you should use the cutout. I don't remember flow directions and whatever I net num flow direction, TCA and network. Cutout. It is something that we want to do in any case. The map that has to be processed is, for example, TCA. The map to use as mask is the basin. And then here, the basin underscore TCA dot hash. And this extract the map of TCA only in the on the mask area. Okay, and all the same also with the drain. Drain. And the other is the network. Net. And then you have to mark the outlet, the map of flow direction, basin, drain. It is all is explained, I think, in the tutorial.
Don't worry if it's so complicated.
No, we
No,
almost
because, for
finished.
example, in ArcMap is directly in one operation, and QGIS
yes.
is the same. Only do you need to calculate the flow direction, and it's possible to calculate the
Yes, but
watershed complete.
just let me understand. Okay, it did. Definitely not complicated, because at the end you will have all the maps.
Mm-hmm.
But now it's just to be faster to do that. Okay, these tools are maybe not so easy to use, user friendly, but they are very scientific based and are well tested and documented. So this has to be balanced between other GIS software and other libraries, but in any case, in a small catchment where we are, especially where you have problems of debris flow or large wood flow, these tools are developed especially for that part.
This package is included in the graphs, for example.
Not
the same.
no. Now there is an old version for UDIG, and the last version is this one for gvSIG. And then there is also the standalone package, which has only the GUI, this one, and no environment to show maps. So you can use your favorite GIS to show the maps and load your maps. but and separately do the analysis in the
Because
output.
do you are trying the script exportation, for example, in R?
In R, we didn't try. The exportation is in Groovy because we were familiar with that scripting language, and it is possible to implement the support for Python or R, or it is just a matter of resources and what you want, who will use this. If we are the ones that only use it, we developed it using our favorite tools. If somebody asks us to develop things, we want to do that, but in any case, since we do not have any input from outside, we don't know even what is better or what the people will need. So I think it is almost everything. It was just an introduction of the analysis. As I said, you can find everything in the presentation and in the tutorial. If you have any other questions, just ask me, and just let me know something.
Thank you very much.
You're welcome. I hope you enjoyed and you will find these tools useful. Thank you to you too for attending the workshop.